We are going to sketch the graph of our function f of x is equal to x divided by x squared minus 9. This is a classic function to graph. It is a rational function, and we are going to have both horizontal and vertical asymptotes. Just to make things easier, I have written down our first derivative and our second derivative, so we can just focus on graphing and not have to worry about those calculations. We're going to start by looking at the domain. Whenever we think about the domain, we want to look at points where our function might be undefined, and that is going to be where our denominator, x squared minus 9, is equal to 0. And this is going to be at x is equal to plus or minus 3. So we can say that our domain is going to be from minus infinity to minus 3, union minus 3 to 3. We're just bypassing minus 3 and 3, union 3 to infinity. And then let's also go ahead and write down that we are going to have a vertical asymptote at the points that are not in our domain. And that is where x is equal to 3 and x is equal to minus 3. Now let's look at intercepts. I think it's easiest to find the y-intercept first. So we're going to let x be equal to 0. And if you go back up here to our function, you can see that f of 0 is equal to 0. So our intercept is 0, 0. And this is both the x and the y-intercept. Now let's go ahead and look at symmetry. I'm going to go ahead and rewrite our function because that's what we're going to have to look at. It is x divided by x squared minus 9. To find symmetry, what you want to do is you want to find f at minus x. So wherever you have an x in the function, we're just going to plug in minus x. So this is minus x, all divided by minus x quantity squared minus 9. And this is minus x, all divided by x squared minus 9. And you can see that this is minus f of x. This tells us that we are going to have symmetry about the origin. So let's write down it is symmetric about the origin. Let's now look at asymptotes and end behavior. We already found that we have a vertical asymptote. Now we need to think if we have a horizontal asymptote. Let's look at our f again. It is x all divided by x squared minus 9. When we think about a horizontal asymptote, we are only concerned with the leading term in the numerator and the denominator. So we can say that f is approximately x over x squared, which is 1 over x. And this tells us that the limit as x goes to plus or minus infinity of f of x is approximately 1 over plus or minus infinity, which is 0. So this tells us that our horizontal asymptote is y is equal to 0. The other thing that we need to do is look at end behavior, and we can look at this function again to do that. As x goes to infinity, that's going to go to 0, and same thing as x goes to minus infinity. So we can write down that f at plus or minus infinity is equal to 0, and that is directly connected to our horizontal asymptote. As x goes to plus or minus infinity, we're going to go to 0, and we're going to go to that horizontal asymptote. So these match up for a reason. Let's now look at increasing and decreasing intervals. For increasing and decreasing, we need to look at the first derivative. I'm going to write down f prime of x. From up above is minus x squared minus 9 all divided by x squared minus 9 quantity squared. And we need to set this equal to 0. This gives us x squared is equal to minus 9. That can never happen. So our derivative, f prime of x, is never going to be equal to 0. So no critical values from that. But we may get critical values where f prime is undefined. It's undefined at plus or minus 3, but our function is also undefined there. So we have no critical values. A function can change from increasing to decreasing at a critical value or at a vertical asymptote. So I'm going to go ahead and draw a number line. We're going to label this x, and we're going to put our two asymptotes on it. We had one at minus 3. I'm going to put a dotted line there, and then a dotted line here for 3. And we're going to need to find the value of f prime to the left and right of those values. Notice that the denominator that I highlighted here in pink is positive, so we don't have to worry about that. We just need to look at this part right here, minus x squared minus 9. If we pick a point to the left of minus 3 in this region, f prime is going to be negative. If we pick a point between minus 3 and 3, f prime is also going to be negative. Just plug in maybe x is equal to 0. And then if we pick a point to the right, it is also going to be negative. So our function is decreasing in all three of these regions. Let's write that down. It is decreasing on minus infinity to minus 3, union minus 3 to 3, union 3 to infinity. And let's just write down that it is never increasing. Let's now think about local max and mins. Because our function is decreasing and it doesn't ever switch from decreasing to increasing or vice versa, we have no local max or mins. The last thing that we need to look at is concavity and inflection points. And we need the second derivative to do this. So I'm going to write down our second derivative, f double prime is 2x times x squared plus 27, all divided by x squared minus 9 cubed. Whenever I tested students on this, I always gave them the derivatives because I wanted to make sure that I was testing on the graphing and not on calculating derivatives, because that second derivative is pretty complicated. We are going to see where this is equal to 0. It is equal to 0 when the numerator is equal to 0. X squared plus 27 is never 0, so we're just going to get that x is equal to 0. And let's go ahead and let's draw our number line. We're going to put our value x is equal to 0. And then don't forget, we always have to put our vertical asymptote values on here too. This is minus 3 and 3. Because concavity can change at a vertical asymptote, we are looking at the value of f double prime. Since our derivative is so complicated, in the left region and the right region, we only need to look at the leading term. So we're going to look at this leading term divided by that leading term. So we're going to say that f double prime is approximately x cubed all divided by x to the 6th. That's x squared raised to the 3rd. So this is 1 all over x cubed. So we're going to look at this in this region and in this region. In the region on the left, 1 over x cubed is negative, so f double prime is negative. And in the region on the right, it is positive. Now, we can't do that for these two regions in between. So So I'm going to let x be 1 and then -1. F double prime at 1. Let's see, this is positive up on top. We don't care about the value. We just need to know positive or negative. And then negative down below. So this is less than 0. So we're going to put a negative here. And then F double prime at -1. The top part's negative, and then the bottom part is negative, and this is going to be greater than 0. So we can put a plus right there. Now we can think about the concavity. It is concave down here and here, and it's concave up here and here. We'll write down concave up from -3 to 0 and from 3 to infinity, and then concave down in the other two regions from -infinity to -3, union 0 to 3. Now let's go ahead and put all of this information on our graph. I think it's easiest to start with our asymptotes. We found that we have a vertical asymptote at -3. So let's go ahead and let's put that in. And we have one at 3. Put that one in. And then we found that we had a horizontal asymptote at 0. I'm going to do this slightly above here so we can see it. Now let's go ahead and let's put in our points. We have an intercept at 0, 0. And do we have any other points? We do not. Now let's look at increasing and decreasing. It is always decreasing. So let's just draw a light pink line like this. It's decreasing, decreasing, decreasing. We'll erase that when we get done. And now let's look at concavity. It is concave up between -3 and 0 and 3 to infinity. So we're looking at concave up here, and then concave down here and here. Now we can go ahead and graph our function. To the left of -3, it's going to lie below the x-axis because it's concave down and we have to follow the asymptotes. So it's going to look like this. And then in between -3 and 3, it's going to change from concave up to concave down. So it's got to look like this. And then to the right of 3, it's concave up and decreasing. So it has to look like this. Now let's go ahead and let's erase all of these other pink lines. And there's the graph of our function.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.